Okay. All right. So welcome, scholars. I'll check Zoom for any latecomers around the 15-minute mark, like I usually do. Welcome. We are at the end of week 14. We are in the home stretch. Like this is all going to be over in the blink of an eye. So a brief synopsis of the remaining schedule. So today we're going to be working on the last of the new material, which is section 6.4. We're going to do as many homework questions regarding that section as we can. And then we break for the weekend. Next week on Monday, we only meet on Monday next week. And we'll use that day to review exam 1. That Wednesday, the 23rd, we're not going to meet. So a week from today, we're not going to meet. That's going to be the Thanksgiving holiday. So, take that time. You want to maximize your time with like your loved ones, spend time with your loved ones, eat some good food, relax, get your work done, things of that nature. Position yourself for success. We're still in a time period where anybody that wants to get out of this class that wants a decent grade, you can get it. You just got to make a plan and go for it, right? You got to just make a plan and go for it. But anybody that wants a decent grade can still earn one in this moment right now. So we break for the holiday break, the Thanksgiving break, and then we come back. And we're only going to meet on that. We meet 2 more times, that Monday and that Wednesday. So that Monday we'll review exam 2 in preparation for the final. That Wednesday we'll review exam 3. That Wednesday, November 30th, is the last day of class. I'm under the impression that Thursday and Friday, December 1st and 2nd, is the reading period. So you shouldn't be meeting in any of your courses. We already don't meet on Thursday and Friday, but Now, after Wednesday the 30th, you're not obligated to attend, but more than likely I'll be online, like I'll be here on Monday and Wednesday during the week of finals. You're not obligated to attend those sessions. I'm just going to be available if you have questions. If you're working on your final and you're stuck and you need some help, I can help you. Otherwise, that 30th will probably be the last time that you'll be required to be live in attendance. So I think I scheduled for your final exam to become available Sunday, December 4th at 11:11 a.m. And it'll be due Friday, December 9th at 11:59 p.m. Right, so that's that hard deadline. So not only will your final exam be due, but everything on Pearson is going to be due. So what that means is that if you need to go back and redo or improve any scores, now is the time to do it. If you're trying to just go back and redo old assignments to improve your overall score, I would encourage you to prioritize your old exams as they count for 80% of your overall grade. The last thing that you want to prioritize is the old homework, because that's going to be a lot of work for little points. The old exams, that's going to be the most bang for your buck, right? I think that's really it. Let me check on Zoom one more time before we get the party started. Okay. All right. So for today, so for systems of equations in 2 variables, we're going to go through as many homework questions as we can. So which order pair is the solution to the given system, right? Let me see. So if you plug in 5, 5, you have negative 15 plus 5 is indeed negative 10. That checks out. 10 plus 45 is 55. So A is a solution. We're just going to go with A because I think we can only choose one here. Okay. Determine which of the order pairs are a solution to the system. So for something like this, I feel like it's a little bit better if you just go ahead and solve the system instead of plug and chug all of those, right? So I'm going to go ahead and take a screenshot. I'm going to cut it there, here. Okay. Then I want to hit done, and I want to copy and delete. I'm going to hop over here and paste that image. Allow the paste. Every time it feels like every time I turn around iOS, Apple is doing some kind of update. So these features are a new update. All right, let me crop. Just their copying features, screenshotting features, but this is fine. This is better because it gives you this option to copy and delete. That way I don't have like a slew of like just random screenshots of this kind of stuff. Okay, so to solve this system, to me, I think I'm going to choose to do the elimination method because it looks like the X is easier to eliminate than the Y, right? So let me start by getting a copy of the original. We have 5x minus 3y equals 8, and we have negative 10x plus 4y equals 12, okay? So what I'm going to do, I'm going to multiply the first row by 2, each term by 2, okay? When we do this, we'll get 10x minus 6y equals 16, and then just the second equation just comes down, negative 10x plus 4y equals 12, okay? So then now we've achieved our goal. We got one variable to have the same coefficients with opposite signs. So now we can add the two equations together. A number plus its opposite adds to 0. Negative 6 plus 4 is negative 2y. 16, 26, 28. Divide both sides by negative 2, and y equals negative 14, okay? So if this is our y, we can use this to go and solve for x. I think I'm going to choose the first equation to solve for x. And I'll just work over here. So then we have 5x minus 3 times negative 14 equals 8. 30 plus 12 is 42. So subtract 42 from both sides. We subtract 42. 12, 14, negative 14, it sounds like. So then x looks like it's a negative 14 over 5. Okay. So then it sounds like the solution to the system is negative 14 over 5, comma, negative 14, right? I don't think that was one of our options. So let's look and see what we're going to do. Style. Okay, let's just go with that. Now, when we hop back to Pearson, it's none of these, right? It's nowhere in that list, so we're going to choose D for none of these. Check the answer. Okay, let's go on to the next question. Solve the system by graphing. Okay, so notice that the highest variable on any equation is a 1. So both of these equations are linear. So these are basically just graphing lines. So I'm going to click to enlarge, and I'm going to set each one equal to y. So what I found was easiest, since these are lines and we just need 2 points, I'm just going to make 2 random lines, right? And then I'm going to go and edit them. So now with the first equation, if we solve for y, we're going to get y equals x plus 2. So if it's x plus 2, that means our y-intercept is 2, like that. And then the slope looks like it's what, positive 1. So then if we go right 1 and up 1, we're going to be at what, 1, 3, right? 1, 3. Okay. So that's the graph of the first equation. So again, for me, for something like this, it's just easier to plot. Like just make 2 random lines and then drag them to the right place. So then for equation 2, our y-intercept is 16. So we're going to go to the point 0, 16. And then the slope is negative 1. So then that means we're going to be at the point 1, comma 15. So then the second point, I'm going to move it to 1, 15. Okay. So it looks like these two cross at 7, 9. 7, comma 9. Right. Let's hit save. Check. Okay. So they cross. So for A, the solution, the order pair that we get was 7, comma 9. If we check really quickly, 7 minus 9 is indeed negative 2. 7 plus 9 is indeed 16. So I'm just going to check. Okay, on to the next question. Okay. graphical method and check your solution. Okay, so basically they're asking us to graph again. What's the time? I'll check attendance in about 2.5 minutes. Okay, so we have two more lines again. So I'm just going to use my line tool and just make 2 random lines, and I'll drag the points later. Okay. So now for the first equation, if we solve for y, we're going to get y equals negative 3x plus 6. So that means our y-intercept is 6. Right there. Okay. And then the slope is negative 3. So if we go down 3 and right 1, we're going to be at 1, 3. So the second point needs to be at 1, 3. 1, 3 right there. Okay. So then for the second equation, it's the same thing, right? So we can just put them on top of each other. So yeah, these are the same equation. Okay, let me hit save. Check my answer. Okay. So then because one is a multiple of the other, we have implementing solutions, and all solutions are going to take on the form x comma negative 3x plus 6. All right. And that's basically comes from the y. So infinitely many solutions, but they all take on the form x comma y, where y is at negative 3x plus 6. Okay. All right. So let's see. It says do not solve. So in order for it to be inconsistent, these would have to be parallel lines. These lines are not parallel. And one is, and then in order for it to be dependent, one equation would have to be a multiple of the other. And then, so if you look, one equation is not the multiple of another. So then that means that this system is consistent and independent. So we're going to go with C. They're not parallel and they're not multiples of each other. Okay. Now, if we multiply equation 1 by 3, 3 times 5 is 15, 3 times 6 is 18, 3 times 11 is 33. So that means the second equation is a multiple of the first. So that means the system is consistent and the equations are dependent. Okay. And again, if anything is not clear, feel free to unmute yourself. Let me do this one and then I'll check my attendance. Okay. So let's see. Now, if we multiply equation 1 by 2, 5 times 2 is 10. Negative 7 times 2 is negative 14, but 9 times 2 is not 27. So these two equations were almost parallel, but you know, they're parallel. I mean, sorry, they are parallel, but they have different y-intercepts, right? So that means the system is inconsistent. These are parallel lines with different y-intercepts. Okay. Let me check on you guys in Zoom. Okay, you guys are looking good. Okay. All right. Solve the following system of equations by the substitution method and check the solutions. Substitution, right? Okay. So if we're doing substitution, notice that equation 2 is we've already solved for y. So then we want to take that and plug it into equation 1. I was kind of hesitating for a moment to see, well, maybe there's a quick way I can do it, but I think the simple way here is just to take some notes and write it out. Okay, so that's what we're going to do. So I'm going to get a copy from here. That's good there. That's good. That's good. I'm going to hit done. I want to copy and delete. And we can hop here. Come on. I'm going to paste the image here. Allow the paste. Awesome sauce. Undo. Let's just paste again. All right. Looks like we're in business. All right. So we are being encouraged to solve it by substitution. So we were fortunate, they've already solved for y in equation 2. So then we're going to take that and plug that y into equation 1. So then we'll have 8x minus 4 times y, but y is 6x plus 32 equals negative 32, okay? So then we can distribute the negative 4. Notice at this point we have one equation, one unknown, so we can solve. We get 8x minus 24x. 4 times 3 is 12, so 128, negative 128. Okay, if we combine like terms, 14 plus 2 is what, negative 16? If that were 40, 60 plus 20 is 88, plus another 8 is what, 96? So then 96. Is that what, 5? 50 plus 36, 60 plus 36, 96. So then x equals negative 6, okay? So we got this result for x. So then we can use the y, just plug that into the equation that had y. So then we're going to have y equals 6 times negative 6 plus 32. That's going to be negative 36 plus 32, which is what, negative 4. Okay. So then our claim is that the solution, or the order pair, is going to be negative 6 comma negative 4. Okay. Just for the sake of time, I'm just going to go ahead and submit it in Pearson and not check it. Negative 6, negative 4. So we got one solution, parentheses, negative 6 comma negative 4. Okay, let's check it. Solve by substitution, so it's kind of the same thing. Okay, let me start by getting a copy of this guy. Okay, let's hit done, copy and delete. Let's give ourselves some space and paste. Allow the paste. Cool. Here we go. Let's put it about there. So this is kind of a repeat. Let's see. It looks like it's easiest to solve for y in equation 1. Okay, so from equation 1, if we're going to do substitution, we add and subtract, we're going to get y equals x minus 3. Okay, then we take this and plug it into equation 2. So then we can say 4x plus 3 times y, but y is x minus 3 equals a negative 16. Okay, we have one equation, one unknown, so we can solve. We'll get 4x plus 3x minus 9 equals negative 16. We can add 9 on both sides. Negative 7, and we get a 7x here. So then x equals negative 1. Okay. So then if x is negative 1, that means that y is going to be negative 1 minus 3, which is negative 4. Okay. So then our claim, the solution to the system is going to be negative 1, negative 4. Okay, again, just for the sake of time, give me just a moment. Left off here. Okay. So we got -1, -4. So we got one solution. -1, -4. Okay. They're still encouraging the substitution method. This is fine. Let's just go ahead and knock this one out. Okay. Substitution, that's fine. So if we solve for y from the first equation, we get y equals 2x minus 9. Okay. Then if we take this and plug it into the second equation, 4x minus 2 times 2x minus 9. Wait a minute. Times 2. Oh, this is inconsistent, right? Because times 2 will give us a 4, times 2 will give us -2, times 2 is not 12. So that means that it's these are parallel lines with different y-intercepts. So it's going to be inconsistent. So it's going to be the empty set. Okay. We're halfway through class today. Okay, let's keep going. Substitution method, okay, let's give it a go. So this is a nonlinear, but that's fine. Just do the same thing we've been doing. So I just like to include the question ID, so that way if anybody reviews this, they know where in the text this is coming from. Let me copy and delete. Give myself some space and paste. Okay, that's good, about like that. Okay. So substitution method, right? Yeah. So if we solve from y from equation 1, we get y equals x minus 1, okay? So if we take this and plug it into equation 2, we'll have x squared minus x times y minus y squared. Okay, equals -19. I'm going to expand this all the way out and set it to 0 and solve. So then we'll have x squared. See here, we can distribute the -x. Okay. So then we'll have -x squared plus x. Let's expand this guy. It's going to become x squared minus 2x plus 1. I'm going to go ahead and set this equal to 0. Another thing we need to do, let's go ahead and distribute this negative. A number plus its opposite as the 0. So then we get x minus x squared plus 2x minus 1 plus 19 equals 0. If we keep going, I'm going to multiply everything by a negative because I just want my leading coefficient to be positive. So that's going to be plus x squared. Now, normally that would be a 3x, but since we're distributing a negative, we're going to have minus 3x. That would be 18, but now we're going to have minus 18. So then this is factoring a trinomial. So we should get something of this form, x and x. 1 is plus and 1 is minus, 6 and 3, right? Negative 6 and positive 3. Notice that negative 6 times positive 3 is 18. Negative 6 plus negative 3 is negative 3. Sorry, negative 6 plus 3 is negative 3. So then solving this using the zero factor property, x equals negative 3 and 6. So then we need to find the corresponding y. Now we said that y was x minus 1. So then when x is negative 3, then y is going to be negative 4. When x is 6, y is going to be 5. Negative 3, negative 4, comma 6, comma 5. Okay. Negative 3, negative 4, and 6, comma 5. Okay. On to the next question. Okay, so now before we try to solve this, notice if we multiply equation 1 by what? Negative 5, we get negative 5x plus 15y, negative 25. So that means equation 2 is a multiple of equation 1. So that means there are infinitely many solutions, and they're going to take on the form x comma, so we need to solve for y, negative x plus 5. Okay. So it's going to be 5 minus x. We said negative x plus 5, divide by negative 3. So it's going to be 1 over 3 times x. Let me think about this again. Subtract. Negative x plus 5, so positive 1/3 x minus 5/3. Okay. Basically, I'm solving for y. Okay. Elimination method. Okay. So notice that this one is non-linear. So we're going to do what we've been doing and just try to catch the changes. So let's put it like that. I'd like to include the question ID. I'm going to hit done, copy and delete. Okay, that's good about there. Elimination method. Let me start by getting a copy of the original. So we have this 3x, come on. 3x squared minus 2y squared equals 25. And then we have 4x squared plus 3y squared equals 39. Okay. Something like this, I feel like it might be a little bit easier to use U substitution. I mean, I feel like it's simple enough in this form. Let's just try to work with this. All right. Okay, I feel like because the numbers are a little bit smaller, I'm going to try to eliminate this y. And I think I am going to go ahead and do my U substitution. So for U substitution, I'm going to say let U equal x squared, and I'm going to let V equal y squared, right? So I'm going to rewrite these into this linearization. I can barely say the word, but you know, it's basically U substitution. So then we're going to get 3u minus 2v equals 25, okay? And then we get 4u plus 3v equals 39, okay? So then if we solve this one, let me see. I'm gonna cancel out my v. I'm gonna multiply the first equation by 3. So I'm gonna multiply everything here by 3. And the second equation, I'm going to multiply by 2. Okay. When we account for these changes on top, we get 9u minus 6v equals, what is that, 75? And then we get 8u plus 6v equals 60 plus 18 is 78. Now we can add these two together. A number plus its opposite adds 0. Okay. 17u equals 140 plus what, 13? 153. What is it, like 6? Hey Siri, what's 153 divided by 17?
153 divided by 17 is 9.
9, I was close. I was almost there. Okay, 9. Okay, let's go back and solve for v. Okay, I'm going to use the first equation. So then 3 times 9 minus 2v equals 25. 27, we subtract 27. All right, so then v equals 1. Okay, so then we need to go back and put everything back, right? So then if x squared equals u we got was 9. So that means that x squared equals 9. We take the square root, we get x equals plus or minus 3. Okay. And then for v being 1, we have y squared equals 1. So then y equals plus or minus 1. So it looks like we have 4 possible outcomes. We got -3, -1, -3, 1. 3, -1, 3, 1, right? You got to do all combinations. Now we should check to make sure that all 4 of those ordered pairs work in the original. I'm just gonna submit them. 3 and 1. Okay. This one. So parentheses, -3, comma, -1. And then the next one, -3, comma, 1. And again, I should be checking these. I'm just submitting it for the sake of time. 3, comma, -1. And the last one, 3, comma, 1. Okay. I'm gonna go with those 4. All right. We'll do one more and then we'll call it a day. Hopefully it's not too terribly long. Solve the system by the elimination method and check your solution. Let's see. If we multiply equation 1 by -7, we'll get -7x. We'll get +7y. So that means that the system is inconsistent, right? because the variables are going to cancel, and we're going to finish with the false statement. So the solution set is the empty set. Okay, let's do another one. Elimination. All right, this one is infinitely many solutions, right? Because if you take equation 1 and multiply it by 2, you're going to get 6x, you're going to get 8y, and you're going to get 2. So everything's going to cancel. You finish with the true statement. That means we have infinitely many solutions, and they're all going to take on the form x comma. Now we need to solve for y. So minus 3x. Okay, so that's going to be a negative 3 by 4x. Okay. Plus 1 by 4. So no matter what x you choose, y is going to take on this form. Okay. All right, that's enough. Are there any questions? Did you guys have any questions for me? Okay. So I'm going to go ahead and make a copy of what we worked on available for you guys. Let me see. Number 1, this one, notes, updated daily, week 14. All right, yeah, that's fine. Send to box. Okay. So when this bar finishes loading, you'll get a copy of anything that you saw me working on. And if there aren't any burning questions, we're going to end the session here. And from one beautiful mind to another, enjoy your weekend, guys. Take care. See you next time. Same place, same time. Peace. Okay, so if you're just joining us, I just wanted you to know I got you, and I just added you. I gave you attendance credit for today. All right, but we're logging out. So I'll see you next time, same place.
All right, bye. Thank you.